In this case we have two balloons and they have a charge of positive 2.67 times 10 to the negative 6 coulombs, because we're just converting out of the microcoulombs, and 9.76 times 10 to the negative 6 coulombs. And because of their similar charges, they're going to repel each other with a force of 0.50 newtons. What is the distance? So this one's asking us for a different value. And it's important to understand that we can actually use this to calculate the charge on an unknown object. If we know it has a charge but we're not sure how much, we can actually do all these measurements of the force and the distance to calculate the charge of the unknown one. Let's look at our equation. F equals K Q1 Q2 d squared. If we imagine this F over 1, we can cross multiply, and we get F times d squared equals K Q1 Q2. Now we're going to divide both sides by F. This gives us d squared equals K Q1 Q2 F. However, I don't want d squared, I want d. So you have to take the square root of both sides. Q1 Q2 over F. So now we can plug into our equation. And let's just not forget the square root. We know that K is 9.0 times 10 to the 9th newtons meter squared, coulomb squared, times 2.67 times 10 to the negative 6 coulombs times 9.76 times 10 to the negative 6 coulombs divided by 0.50 newtons. So if you look at the units, newtons cancels out and coulombs cancel out, giving you meters squared. So when you take the square root, so if you put this into your calculator and then take the square root and round to two significant figures, you get that the distance between these two charges is 0.68 meters. So the hardest part of these is putting all those complicated numbers into your equation and remembering to do the square root in this one, because it's not something we do very often, so it's easy to forget.